Hearty welcome to the video series on questions for revision. At this video, we will see questions from indefinite integral. Reference material in all chapters in class 12 mathematics is available easily to all the students, but the students are not able to gather necessary help since detailed explanation of the solution step they need, recollection of the concepts required for the solution at required places they need, tips to do problems with slight changes they require, and tips to reduce the errors also they need. The above needs of the students is taken care at this tutorial series. Revision means looking back over previously learned information, ensuring that it is clear and fresh in the mind, which is required for every child. 10 questions per selected topic is compiled, and the answers to these compiled questions are presented in PDF and video format. Kindly start your revision by downloading the file with questions for revision. This material is only a supplementary to the revision strategies planned and executed by your experienced teacher. Question number 1. Integral 2 upon 1 plus cos 2x we have to check out. Now you know that 1 plus cos 2x can be written as 2 cos square x, 2 getting cancelled, therefore it is secant square x, therefore the integral is tan x plus c. Therefore the option is B, tan x plus c. Question number 2, integral log x upon x square dx. Here the children will get confused thinking that differentiation of log x is inside the integral, therefore you will try to do this problem by substitution method. But remember, it is x square is there in the denominator, not x. Therefore this problem to be done by integration by parts, logarithmic function and algebraic function. Therefore let us take u as log x, dv as dx by x square, du is dx upon x, and v is minus 1 by x. Put it in uv minus integral v du form, uv minus integral v du. You will get minus 1 by x log x plus 1 by x square dx, and integration of 1 by x square is minus 1 by x. Therefore the answer by taking minus 1 by x outside, minus 1 by x into 1 plus log x plus c. Be careful with this problem. This problem is not a problem of substitution, problem of integration by parts. Question number 3, 1 upon sin square x square cos square dx. The denominator to be converted into a single trigonometric function, or otherwise you can add and for that one you can replace it by sin square x plus cos square x because addition is 1. Divide it into 2, 1 by cos square x plus 1 by sin square x. Therefore it will be secant square x plus cosecant square x. Direct formula available, tan x minus cot x. This problem can be done by multiplying and divide by 4 and all also you can do. But final answer you should get, that is why I have done by replacing 1 by sin square plus cos square. Tan x minus cot x is the answer. Problem number 4, e power x into 1 plus x by cos square into x into e power x. By looking at the given problem itself, I can visualize that the differentiation of x into e power x is there in the numerator. Therefore I will do it by substitution. Du is x into e power x plus e power x by using product rule. By taking e power x outside, e power x into 1 plus x. It is in the numerator. Therefore it will become du upon cos square u. Secant square u integration is tan u. Therefore it is tan of x into e power x plus c. The answer is A. Move on to question number 5. Evaluate 2x minus 6 by square root of 7 minus 6x minus x square, coming under a special type linear factor by quadratic factor inside the square root. You know the procedure. Put linear factor is equal to k into d by dx of the quadratic factor plus L. We have to get the values of k and L. I have equated the x coefficients and get ks minus 1. Equating the constant, I got L is equal to minus 12. I am putting it inside the integral sign now. The integral is split into 2, minus 6 minus 2x upon the square root plus minus 12 upon the square root. But in the first integral can be done directly because dx upon root x is 2 root x. Numerator contains differentiation of the quadratic factor inside the square root. You can directly write it as 2 into the square root. Now we have to evaluate only the second integral. Now for that, be careful. There is a minus sign for x square. For that to be taken outside. X square plus 6x can be written as x plus 3 the whole square minus 9. Be careful. Minus of minus sign is plus 9. Therefore 16 will come out. Here only most of you will do mistake. 7 plus 9 will be there, not 7 minus 9. Well, therefore this is 16 minus x plus 3 the whole square. We are applying the formula square root of a square minus x square formula, sin inverse x by a. Therefore it is sin inverse x plus 3 by 4 plus c. Move on to question number 6. Evaluate tan inverse secant x plus tan x if x lies between minus pi by 2 to pi by 2. Secant x can be written as 1 by cos, tan can be written as sin by cos, but it is 1 plus sin x by cos x. Now I have to replace this cos pi by 2 plus x is minus sin x and sin pi by 2 plus x is cos x. I am replacing them. Therefore sin x is written as cos of pi by 2 plus x and cos x is written as sin of pi by 2 plus x. We have a formula 1 minus cos x formula. It is 2 sin square x by 2. Sin x formula is 2 sin x by 2 cos x by 2. I am replacing them. I am getting numerator as 2 sin square pi by 4 plus x by 2. Denominator 2 sin pi by 4 plus x by 2 cos pi by 4 x plus a by 2. You will get tan of pi by 4 plus x by 2. Therefore pi by 4 plus x by 2 you have to integrate. Final answer is pi by 4x plus x square by 4 plus c. Please check out the numerator 1 plus sin x is replaced by 1 minus cos of something. There is a technique in this problem. Then only it will get simplified with the denominator. Fine. Go to question number 7. Evaluate sin inverse x by 1 minus x square whole power 3 by 2. I will put x is equal to sin theta. This problem can be done directly by integration by parts, but when you do the substitution, the problem will get reduced. But dx is cos theta d theta. Theta is sin inverse x. I am replacing everything. Denominator 1 minus sin square theta whole power 3 by 2 into cos theta d theta. For denominator is cos cube theta, theta by cos cube theta into cos theta, which is theta upon cos square. What is 1 by cos square? Secant square. You see how the problem has been reduced to a problem theta into secant square theta, which can be done by integration by parts by taking u, dv, du, v. Put it in uv minus integral v du form. All of you know that what is integral tan? It is log secant. The only thing in this problem where when you do the substitution is you have to talk about the resubstitutions. Therefore tan theta is sin by cos and secant is 1 by cos, and I have done the substitution for sin theta only. Therefore I am checking everything in terms of sin. Sin by root 1 minus sin square, log of 1 by root 1 minus sin square. Now do the substitution now, because you know that sin theta is x and theta is sin inverse x. Simple. Well, let's move on to question number 8. Evaluate x square plus x minus 1 by x square plus x minus 6. And this problem to be done by integration by partial fraction, but the children will be tempted to factorize the denominator. Yes, denominator can be factorized. Directly they start that work by doing a by something plus b by something, but check out, this is not a proper fraction. Why? Because numerator degree and denominator degree are equal. Improper. To be converted into proper. How to do it by proper? Divide numerator by denominator. I will multiply it by 1. Whenever in normal division, what will you do? Change the sign and add. That may be the idea which you will be having. Therefore when I do the subtraction, I will get it as 5. You have to put it in the form q plus r by d. What is q? Quotient plus remainder by denominator or divisor, whatever may be. Therefore, I am writing it as 1 plus 5 upon x square plus x minus 6. This is converting the improper into proper. Therefore, I have to integrate the right hand side. Very simple integration. The right hand side x square plus x minus 6 is x plus 3 into x minus 2. Now that can be done by integration by parts. I am finding the values of a and b. A is minus 1 by 5 and b is 1 by 5. Therefore, I am doing the integration now. The integration is very simple one because it is log of and log of. Therefore, the final answer is x minus log x plus 3 plus log of x minus 2. Because that 5 is getting cancelled, you are seeing over there. Simple. Well, let us go to question from assertion and reasoning. Assertion is f dash of x is given, f of 0 is given, then you have to find f of x. And reason is the formula for integral x power n is given. Let us see whether the assertion is correct. F dash of x is given. How to get f of x? Integrate. When you integrate, you will get plus c. But to get the c, f of 0 is given. Therefore, I am using that. Now c is 0. Therefore, f of x is x square by 2 plus tan inverse x. Therefore, assertion is true. Now, the reason is formula given. Formula is also correct. But this is not used to get the value there. Therefore, R is not the correct explanation of A. Because there is you are having a tan inverse x formula also. That's well. Let us go to question number 10. You have been given integral tan x minus x by tan x plus 1 is log of something, and you have been given a formula also. Tan x minus 1 by tan x plus 1, taking minus sign outside. This looks like the formula tan pi by 4 minus tan x by 1 plus tan pi by 4 tan x. Looks like tan x minus tan y by 1 plus tan x tan y, which is tan of x minus y. Therefore, you are knowing the formula for tan of something, log of secant pi by 4 minus x by minus 1. Don't forget that minus 1 because coefficient of x is minus 1. Therefore, integration is log secant of pi by 4 minus x. Yes, assertion is true. But the formula of tan x minus y is used here to prove the result. Therefore, both A and R are true, and R is the correct explanation of A. Success is dependent on efforts. All the best, students.